Okay, so I've kind of written some code here, and so you might want to pause the video and see what we got here. I'll talk about what we have here. This is in the main.c program here. First off, we have to include the header file for the API we just wrote. And then this is just to test it. My temperature sensor, it's been through the ringer, so the actual pressure and temperature readings aren't working properly, but we can still see how to debug it with being able to read all the coefficients in. So we have this float temperature, float pressure, because that's what we're doing. Start the I squared C, we start the device, and then we read the pressure and temperature, and then we have to use the pressure and temperature variables just so that we so it will actually execute this line of code and actually, give us some numbers back here. All right, so with that being said, before I enter debug mode, what I'm going to do here is I'm going to go back into this I squared C here and for my API, and I'm going to, because I can only test um, the I'm sorry, I'm losing my mind here. Because I can only test the coefficients right now, because as I said, the pressure and temperature sensor on my device is broken. I'm going to just put a stop point here, a breakpoint right here, and we could add a couple others here. So let's just go ahead and add. I mean, we can do step overs, but we're just going to go ahead and add several breakpoints there, so that we can just stop at each one of these lines and see what's going on with the data. So we're going to hit enter debug mode here. And it takes a second to enter debug mode. It's programmed, but it's having to start up the debug mode. Oh, okay, I have too many breakpoints. So let's just take that out here. It doesn't like it when apparently you have too many breakpoints. So I'm just going to take a bunch of them out. And like watch points, breakpoints, Okay, there we go. So it's here. Now, if you use this step over, it will go to the next line of code. But if you hit the green arrow, resume execution, it's going to go to wherever the next line of wherever the next breakpoint is. So if I hit that, it jumps all the way to where I have it here. So now first let's look at locals here. So it's got the local variables here. Now first off, yours is probably looking at memory or registers, like registers like this. And so you can see all this. You probably don't have this tab. So let me maybe delete all of these so I can show you how I added them in. So we're going to delete all of those. And maybe just close that. All right. So you probably have the memory. So this is actually like the memory that's physically on like the device. And actually you can kind of see the first bits here are the actual program that we've written in all the machine code and everything, and we don't know what all of that means. I mean, we could look it up, but you can see if you go through, this is what's stored in the actual chip as far as our program. And then of course we can look at the registers. Red means the value has changed since the last line of code. And so and right now it's giving the program counter is equal to 1E6. So if I were to go to my memory address and look for 1E6, this is where I'm currently at in the program. And then it would go and execute these kinds of lines of code as far as what to do next and everything else like that. I mean, it knows what this information is, the processor. So, but then locals is what we're going to want to probably deal with here right now. And see, we got the locals for the MPL ones and the data. So those are the locals that we've defined in this one here. Now, we can also add additional ones, like, because remember these are global variables, and you can hover over it and it's got what its value is, but you can actually add a watch point here. add watch point. Why is it not letting me do that here? That's weird. It was letting me do these just fine the other time. Well, we'll continue on here and show you how you can look at them. I think it's because I was actually accessed on it. So I'm going to step over here one. And so it's read the data, and we can see it's got 4.6 in the data. That changed. And you can also do it here. I'm going to put it in binary. So you can see 01000110 is what's read in. And then let's go ahead and look at the 16-bit integer here. So we can see all 16 bits. It's currently 0 because I had predefined it to be 0. Now I'm going to set it equal to it. Now we said that this is just going to go into the lower bits right there. So if I hit over, step over, we can see literally we've pasted this right into here. And you can see that it's changed. Now we said, wait, these need to be the most significant bytes. So now we're going to do our bit shifting. So again, I'm just going to step over. Step over actually doesn't require me to have breakpoints. So I'm just going to step over that command. And we can say, yep, shifted it so it's in the most significant bytes. All right, now we're going to read the least significant byte of data in. Okay, so we're going to step over that command. And now this is the least significant byte of data. And then we're going to step over that. And suddenly we can see that we've got that binary number stored there. Now, of course, we could store it as, a hex number, or if you wanted to, you could put it as a decimal number. But I like to just look at it binary for now, because that way we can see it between here. Now we're going to want to see what's going to happen to this because it's right now it's at 0. So I'm going to step over. Let's see if I can actually add the watch point now. Yeah, here we go. Add watch point on access is what I like to do. Okay, so add watch then is what we also have here. So let me go back so you can see I did the add watch. First I did add on access, and then I added the watch. Now it's come up here, but now I can just manually click and add here. Like for instance, I could do underscore MPL 115 A2 B1, and then I'm going to copy that. B2 C12. And so we have all of these here, and so we can see these, of course. Great, awesome. But then what I can do again is I can step over one line, and I can see, okay, it's got 2258.25 stored there. Okay, so now what I'm going to do here is I'm going to take some of these out here, and I'm going to go all the way down to the stop here. So I'm just going to let it read all the coefficients in here. So it's definitely read all the coefficients in. But this is where we can now turn to the data sheet and see if what we're reading in even makes sense. Because let's look at an example here. Here we go. So here's an example of reading the data in. So it says A0 is 2009.75. Well, we're getting 2258.25. It's not the same, it's not supposed to be, it's different between devices, but it's in the order of the same magnitude. It's in the 2000s range. But then look here, we got negative 2.6, negative 2.3, yeah, that's reasonable. Negative 0.9, okay, I get negative 1.2, that's still reasonable. Here we get 0.000790. Well, if I do here, it's 0.000, so it's the same number of zeros, 909. So all of these look reasonable. So we can be confident now that we're reading in the coefficients first, because what we're doing now is testing our API to make sure the API works before we, send it out and publish it, and making sure everything works. Now, as I said, if I go down here and add some breakpoints here, I can show you what's going on here with this. I was having some problems with, I don't know why that's there. We'll see what happens when it gets to that. It might spit back, it hates me. I was having some problems with getting the data in correctly, and I finally traced it to the fact that I didn't have it. So now I'm going back here. Now you can see the watch. I still have all these globals that I have access to, but then it's got a ton of locals here. The data read, that's this local here. The MPO1, temp, presh, P compensated. Air is optimized out because I haven't predefined it to be something. That's another reason why you want to kind of initialize your variables so you don't get this weird optimized out thing. And then you can see right here what these are displaying here are memory addresses. But if you hit the plus on here, it's actually showing, okay, this is the value that's stored in that memory address. So right now the value that's stored there is 0. And then this is basically the same thing, and then the temperature is basically stored at 0. But if I step over this, you can see what's going to happen here. So first off, I was checking to see if I was getting an error. The error I can see is 0, which means everything worked fine. But the problem is everything working fine, if I go down and see what data read is, data read didn't change. Now it doesn't mean it didn't read the data, it's just saying, well, I read in 0, so I'm not going to change it because it's still 0. And that's an indication that my sensor's broken, that it's not working properly. So you can go through, and I mean, it will still go through and compute things here. If I go through and do a step over, it's still going to compute things here. Still going to do all of, actually that should say read temperature data. Still going to compute all those things, but it's because the sensor's broken, it's not going to be reading any of these things. Now it's still going to do a computation here. So if I do the, whoops, I don't know, we got to do assembly here somehow. It's got into disassemble there. I didn't want that. I must have hit something wrong there. But let's go down here, add a breakpoint there, and just go all the way down there. And then we can see here, if I look in at this pressure, it's got a pressure here, 193, because you're going to get a number from this compensated pressure, so you're going to get a pressure out. And then we're also going to get a temperature out as well, because you're going to have negative 472 over negative 5.35 plus 35. But you're getting a temperature of 123 degrees. Now, which is clearly not right. The other thing that you have to make sure to do is, besides just hooking it up, there's actually 5 wires, and even when I did this, it didn't work properly, so that's an indication that my sensor's not working, is that you have to make sure to have the shutdown powered up to 3.3 volts as well, because remember that's got to be powered to VDD. So there's actually 5 wires. So I kind of just crammed both of them in there, which is not a good idea. Better thing is to use like a breadboard or split the wires or something like that. But this does show you the code and how to debug it. So at this point, what your assignment is to finish this API and show, do some measurements and give me what you have received for your pressure and temperatures, and see if they match with like what local pressures and temperatures are. I'll give you some more detail on that in an email and an assignment on Blackboard.